Hello everyone, happy Monday. Sorry I couldn't be in the classroom today, but I should be back tomorrow. I just wanted to do a quick recap on what we learned on Friday and where we're gonna go today. So just a friendly reminder, we started talking about functions, what a function is last Friday. And our little function machine here on the front, we refer to the input as the domain, the x values, as well as the independent variable. What comes out of the function machine is referred to as an output or a range, y values, and the dependent variable. Okay, and then we did discuss that a function is a relationship where one or more variables, with one or more variables, and each input, this is the important part, each input has a single or one output. This is so important that we wrote it twice. And this is kind of the theme of this unit. This is not the best highlighter, but it will work. So each input, each x value is only allowed to have or correspond one y value or output. If you just keep going back to this sentence over and over today, you'll be able to answer questions in the forms of tables, set notation, or we call those coordinates, graphs, and mapping diagrams. And today's focus was on graphs and mapping diagrams. Okay. Once again, so on Friday, we talked about this first one being a function because each of those inputs produced one output. Yeah, we see that the output 1 repeated, but that's okay. This -1 only had one answer, one output, therefore it was a function. B was an example of a not being a function because the input of 3 produced 2 different outputs. We can't have that. Okay, therefore this is not a function. Very similarly, our coordinates, 3 produce 3, 4 produce -1, 2 produce 3. Each of these inputs or x values produced only one answer or output, therefore C was a function. And D was not a function because the input of 1 ended up having 2 different answers. We had an output of 8 and -3. So here we go to graphs. I think you guys are going to like this one. In graph, we use something called the vertical line test. So we're going to use the vertical, that means going up and down, line test. And I would encourage you to either use a ruler, a pen, pencil, even your pinky will work, okay? A vertical, going up and down line test. Okay, we know that the relation will not be a function if the vertical line test ever passes through more than one point. So if it ever passes through more than one point. Oops, that's an N. Bless you. Got sneezing kiddos in this house. Okay, so what does that look like? I'm going to take my handy dandy, very sticky ruler that I have here, and I'm going to place it on top of E that has this graph that kind of looks like a smiley face. And I'm going to place the ruler down anywhere, and I'm just going to kind of use the ruler to make or even just imagine a vertical line. So here's my little line I made. I can make that line anywhere. I can do it over here, in the middle, it doesn't matter. Next, I'm going to take my little highlighter and I'm going to show where this vertical line I did in purple intersects or hits that line. And I see that it only hits at one location. The fact that this vertical line that I made only hits this line at one point makes it a function. Because what that means mathematically is each of those x values only corresponded to one y value. Okay? F is an example of not being a function because if I were to take my handy dandy ruler, and again, doesn't matter where I make that vertical line, I'm going to make it right here. If I take my ruler and make or even imagine a vertical line here, I can see that this purple vertical line intersects in more than one location. The fact that it kind of made the zigzag motion and now my vertical line is hitting it or intersecting it in more than one spot, we're going to shut that down and call that not a function. Okay, so we're going to find functions that kind of make those weird like loop-de-loops vertically. They will not be a function. Okay, so that's graph. We're halfway done. A mapping diagram is what you see over here. It kind of maps out data. And what I'd like you to do is just really look, review, take your pencil, highlighter, review the arrows. The relationship or the relation will not be a function if any, of course, of the x values maps to more than one y value. You should probably be annoyed with me saying this by now. Okay, so that's kind of the theme over here. So I'm going to just kind of take a pen or pencil or something and mark. Here's my -4. I see one arrow. The output is 16. This -2, this input has only one output and it's 4. This -1 has one output and it's 1. And this 4 has an output of 16. The fact that I didn't list more than one output for each of these inputs makes it a function. So this one is a function. This guy over here is not a function. And the reason why it's not a function, if you follow the arrows closely, this input of 3 produces an output of both 4 and 16. Once again, we cannot have more than one output for each input. Again, if I go to the store and I decide to buy 3 candy bars, if I go into the first line and I purchase 3 candy bars for $4, I shouldn't go in that same line, same situation, same store without any new discounts and buy 3 candy bars for $16. That doesn't make any mathematical sense. So this is not a function. Okay, so that's pretty much it. What I would like you to do is do Edulastic problems number 11 through 20. They should look like these 2 sections right here. Please practice it. Since I'm not there to give you feedback today, don't hit submit, please. And then the last thing I wanted to remind you guys, it seemed like some of us had a hard time on Friday with domain and range. If you would like, stick around for this video for about one more minute here. Okay, the domain, remember, is a set of all possible x values. And of course, the range is a set of all possible y values. So I'm not going to do all of these, but I just wanted to remind you, if I wanted to find the domain, for instance, of problem A, I would simply copy down all the x values I see. If I wanted to do the range for A, I would just simply copy down all the y values, the range for A. So what that would look like mathematically, you will see these like weird little brackets. And I would simply list all the numbers I see within this x column here. And for the y value or for the range, I would do the same exact thing. I see a 1, a 0, and a 1. I don't have to list the 1 twice. Again, my silly looking bracket there. Again, we're not going to do all of these, but as an example for like C, I see the x value is 3, 4, and 2. Okay, the y values of the outputs, the range are 3, -1, 3. I don't have to write that number if it repeats. Okay, again, we don't have to do all of those, but that's more or less just a quick little recap on how you do domain and range. Those are the first couple problems in Edulastic, okay? At this point, you guys should probably be very close to problem 9. If you want to go in order and just finish it off in order on Edulastic, I welcome you to do that. If not, you guys have until Wednesday. So once again, let's see if you can actually see this a little better on the camera. Here we go. So we're going to go on to identifying functions. Friday, we worked on 1 through 9. Today, I'd like you to focus on 11 through 20. If you finish all of them, please don't submit. We'll do that tomorrow in class. However, you do have until Wednesday to complete that Edulastic, okay? Take care and have a great day.